Hey, this is Matt from Speedscale. I want to take a few minutes to make a short demo of how Speedscale works and how it's able to replicate your environment and provide a developer observability platform that people outside of operations can use. So I wanted to start the conversation by talking about how Speedscale is deployed, since a lot of engineers need to kind of understand the nuts and bolts of how it works before they can build a mental model of it. So I want to start with a Kubernetes deployment. We talk a lot about Kubernetes at Speedscale, not because we don't support other environments, but because Kubernetes makes things so easy for traffic recording and replay. So when you deploy Speedscale, we start with a set of shared components, one of which is an operator. If you're familiar with the Kubernetes operator, you'll understand how that works. Now, once the operator is deployed, Speedscale now has a presence in the cluster where it can either collect data or cause replays to happen, or simulate environments. So if you wish to ingest data or collect new data from a service, we use the sidecar pattern. And just like Istio or Envoy, we work alongside those tools if they exist, but we use a similar pattern. Now, when you go to replay, usually customers set up our operator in a test environment or a test cluster that may be scaled way down and very inexpensive to run, and then Speedscale will automatically allocate resources, cause the cluster to scale up, and then it'll spin back down again when the test is over. This can all happen in the span of seconds or minutes if necessary, and it really helps you keep your cloud costs down because you're not maintaining these staging environments. When a replay runs, we run a series of containers, one of which is a generator, another one is like a service mocking engine or a responder, and then a data collector, just like your normal observability tool. Now, all of these containers are a fraction of the size of anything in your production environment because we aren't actually standing up a copy of the database. We're just creating a network mimic that contains just the information you need. So a lot of times these containers will end up being 50 to 100 megs, and that's it. So that's the deployment. Now, when we get into the actual product, Speedscale, everything that I'm going to do is controllable from the command line or through annotations in Kubernetes or YAML or custom resources. But I'm going to show you the UI version, since a lot of folks just want to fire and forget. They just want to let Speedscale do its thing, deploy the operator, and then use the user interface after that. So I'm in the user interface. Most of the time, we don't have any services here because we haven't started monitoring any of them. But you'll notice that we're tracking the amount of volume coming from each service, the number of requests, to give you a high-level idea of what Speedscale sees in your environment. Now, if I want to go and monitor any service in particular, I hit this Add Service button, and you can see that Speedscale supports a variety of different deployment modes. So everything you can imagine, down to manually entering things with like a command line tool or a UI, all the way up to monitoring from production. All those things are supported. Now I'm going to focus on the front-end service, and imagine that I'm an engineer who works on front-end and knows a lot about it. Now, if you click into front-end, you'll see a view that is familiar to a lot of site reliability engineers or operations folks, and it basically is the health of your application. But it's very different than what you're used to with the normal observability tool because it's a lot deeper. But let me start with the commonalities first. First is we selected a service. The second is we said we want to watch the last 15 minutes, and because it's a live tail, we can decide how often that it updates. So it'll show you continuously updating traffic. We get a rough idea of how much traffic is going into your service in real time and how much is going out. And you can see little hiccups as we go along. Now, from all that data, we construct a service map. The service map is very similar to the ones you see in an observability tool, with one key difference. This was not made using OpenTelemetry. It does not require special configuration or compiling anything or changing anything. We're doing this all from the network, but we're not just showing you the network connections. We're actually decoding the traffic and telling you what's inside. So we build a service map in that way. Now, last thing I want to show is the individual requests. Now, if you have a very well configured application, you might see some of this data, high-level things like which endpoint was hit. What you probably won't see, though, is the actual responses and request data going out with each request. So we actually capture all the headers, we capture the response bodies, and we make all that available for you to work with. Now, we also do some analysis on the data where we identify items like JWTs or OpenTelemetry case IDs, span IDs. We look for common patterns like email addresses, and we put that in interesting data. Now, this is probably where it's a good idea to introduce the concept of AI. At Speedscale, we do more of an enterprise-oriented AI, which is to say we do not train our public models on enterprise data. There's no filtering, or I'm sorry, there's no bleeding out of that data into other models. when you upload things, that's all, you're the only one that sees it, right? It's all segmented, and our models are not trained across it all. But for you and your your particular application, we will use this information to train. So we go through, we understand a lot about this traffic. Now there's one other neat trick here that I think is very helpful. We can also filter. There's going to be a lot of noise in most people's traffic for any like serious application of scale. So Speedscale automatically tries to find something called a session ID. Now, session ID is just like what it sounds. It identifies unique clients or outbound connections. Now, in this case, we have a variety of them. Some of them are based on JWTs, some of them are based on actual email addresses, and some of them are just values that we picked out. This all mostly happens automatically. Now, you can custom configure it, but it's designed to just find what it can find and try to pick the best identifier for a session ID. So what that allows me to do is I can go and isolate a particular user, click OK, and now I've created a filter string or a search criteria that will only pick out this particular Gmail address, and it's a fake address. But so we go through and we show all that data, and you can see where it is in our data. And I want to go and do two things. The first one is I want to save this environment for later use. Now it's probably going to sound strange, but Speedscale gives you the ability to take this 15 minutes of production and copy not only the traffic going in, but also the services that it depends on. So if that's Salesforce, if that's Postgres, if that's MySQL, if that's HubSpot, doesn't matter. Because it's at the network level, Speedscale is able to decode the protocols that we support and replicate them so that when we replay that snapshot, it will feel like your app is actually running in the environment. As long as you do what was done in that 15 minutes, or hours or days, whatever it is you select, Speedscale will have an answer and will simulate and make it think that it's running in production. So I'm going to walk through it real quick. There's a lot of different options you can choose. I'll just show a few of them. I hit the replay wizard, which gets me started on replaying. So to back up, at this point, I have an operator running on a cluster somewhere that I've allocated for this. Maybe it's for my CI pipeline, maybe it's my staging environment, maybe it's just for developers to play around. That cluster will start out very small. Then as I run through this replay, it'll get bigger and allocated up, and then it'll shrink back down again. So this is very different than what you're probably used to, where you're copying big databases out of staging and doing stuff. All that stuff is essentially obsolete with Speedscale because it's able to mimic the databases correctly. So I go through here, I select what traffic goes in, select what traffic goes out, I select my workloads, where I would like it to replay, which cluster I'd like it to go, which workload I'd like to target. I'm going to go and turn on some of my traffic. Again, this is all for a longer demo. But we have a variety of choices we can make. The first one is we can say, I just want to check for correctness, or in testing terms, that would be regression. I don't want any service mocks. You can do that. You can also go all the way up without writing any scripts. You can go all the way up to say, I'd like 100 times the original traffic. I'd like you to simulate all the databases. I'd like you to run for 5 minutes. I want Speedscale essentially to just completely blast my application. I can do that. And then I hit next. And then I hit start replay. Now, in the interest of time, it takes a few minutes for this to run, or at least 5. I'm going to zip to one of these finished reports. Now, in this report, you can see you're getting what you would get out of a normal monitoring tool, which is latency, P95, P99, P50, throughput. You're getting memory consumption, CPU consumption, and latency summary. The difference is we didn't break any customers' experiences in order for this to happen. We tested it like looking into the future by simulating the entire environment. In some ways, what's happening is so complicated that it seems super simple. Speedscale has gone and remodeled our data environment. It has gone and rewired the network and made it seem like this version of the service is actually running in production for 15 seconds, and then it's load testing it or stress testing it. Now you can imagine, you can use this to try to size your Kubernetes clusters for production. You can go to if you're going to do a lift and shift, like you're moving to a new architecture, we can go and make sure the performance is going to stay consistent. You don't have to write any scripts or understand, all you have to do is record and play back. Now, we also do more mundane things, let's say, like check the API for correctness, and that's in our success rate tab. In this tab, we have diff views where we show that we recorded this, but what we got back when we did the replay was what was in this actual tab. So we have these diffs throughout everything to say, hey, this is perhaps not correct. And you can, of course, tune what you wish to be an error, and we can help you determine, well, I was to say that the tool helps you determine kind of where you need to set that threshold. Now, once we've done that, we have now completed a performance test. It would normally have required days or weeks or months and huge expense at replicating an environment, trying to copy production, scrubbing the data, because Speedscale has a built-in PII redaction system. All these things are happening behind the scenes very, very easily. So I want to show one last thing, though, and that is what the developer experience looks like. Now, Everything I just showed you is from a point-and-click interface, and it can be run in a CI pipeline with one command. It's all very straightforward. But I also can do something that is not obvious. I can actually replay this same set of transactions against a process running on my local system, and Speedscale will simulate the entire production environment for me. Now that isn't as helpful because your laptop is very different than production, but it does allow you to catch a bug that you saw in production, bring it back, and safely replay it over and over to try to figure out if you fixed the bug without actually breaking anything. So you can go through this at your leisure, but you can turn on and off service mocking, whether you'd like that. You can do different kinds of simulation. It's all right there. And when I do that, I get the same results in the user interface as I did before. So anyway, I hope this was helpful for you, and enjoy using Speedscale, and we hope to talk to you soon. Thank you.